So the next topic that we'll go over is section 14.8 in your textbook, which is about changing variables using Jacobians. And we know this is the section on multiple integration. If you have heard the word Jacobian before, that's good because we talked about it a little bit when we talked about changing to polar coordinates. Changing to polar coordinates is just one example of changing variables using Jacobians. And in this section, we're going to just talk about it a little bit more generally. So Jacobians are, of course, named after the 19th century mathematician Jacobi. And what he found out is, just like when we do a change of variables for a single integral, like a u substitution, we know that we have to multiply by the derivative in order to account for that change of variables. We'll have a similar thing when we're changing in terms of two variables. So we say if x is a function of u and v, and y is another function of u and v, just like when we changed to polar coordinates, u was r and v was theta, then the Jacobian, which we can denote as del x and y over del u and v, is going to be the determinant of the matrix del x del u, del x del v, del y del u, and del y del v. The determinant of that matrix is del x del u, del y del v, minus del x del v, del y del u. And so what we're going to say is that if we were integrating over a region in the xy plane, a function of x and y with respect to the area, then we can rewrite that where f is a function of x and y, which are functions of u and v, we'll multiply by the absolute value of this term, the Jacobian, and then integrate with respect to u and v. And this region R becomes transformed into a region in the UV plane. So just to give you an idea of what I mean when I say that, if we are talking about a region in the XY plane that we think is pretty well suited to polar coordinates, say something like this, and maybe in the xy plane, this is r equal to 1, and this is r equal to 2, and this is theta equals pi over 6 maybe, and we have theta equals pi over 3. Here. Then we can think about that as a region in the r and theta plane that is rectangular. So it's going to be r is from 1 to 2, theta is from pi over 6 to pi over 3, this rectangle. So if it were already a rectangle in the xy plane, then we wouldn't need to make the change of variables, but it had a circular shape, so it was more suited to r and theta. In that plane, it's actually a rectangle.